Well, welcome back, geology class. This is the attempt at Glacier video lecture number 2. Last time we left off talking about the formation of glacial ice. I think that's where we left off. And I had a picture, and it should have looked like this, where we talked about how glacial ice forms. But I neglected to show you some pictures of glacial ice because it is very distinct. You know it's different from regular ice just by the look of it. Look at the blues that you see in here. Not every glacier is going to be all blue, but when you see some of it break off, like you see here, that blue color can be exposed. It can become very intense at times, like you see in the picture here. It just tells you there's a density to glacial ice that other ice doesn't have. More typically, you'll see a hue like this, where you can just see blues in cracks and crevices and various places on broken or fresh edges of glaciers where they're not covered by snow. And so that notion of glacial ice being distinct, different, formed by a high pressure environment is obvious when you look at some aspects of it, such as you see here. I want to next shift gears just a little bit, and we're going to, not shifting gears, we're going to move on to another topic. And that is, how do glaciers actually move? We talked about how they originate when you get snowfall year after year, building up, and at some point, it reaches sufficient thickness, 30 to 40 meters, that the pressure actually causes a movement in the lower portion, but that previous to that, it will form glacial ice, but there won't be flow possible. So when a snow field gets thick enough and it's forming ice, it's forming glacial ice, but when that glacial ice reaches that 30 to 40 meter mark, somewhere in that, knowing what we know about the character and the nature of ice, it takes that much ice before you start to see a plastic movement to it. And we do call it plastic flow. And you can see that if in this diagram here, there's a hole drilled in a glacier. So this would all be glacial ice. This would be the bedrock that the glacier sits on. So if you drilled at time zero a hole straight down in the ice from the surface down to the bedrock, it would be a vertical shaft. But through time, you'll see that shaft displaced. And it will do so in a kind of a unique way. The lower portion of that shaft that was drilled here, it takes on, first it's displaced the most, but it takes on this curved appearance. Okay, and the upper portion is relatively straight compared to the lower portion, a little curve to it, but it has been displaced a great distance. Okay, now this occurs because when the ice gets to be that 30 to 40 meter thick range, there's enough weight on the lower portions that it behaves kind of like Play-Doh. And it squishes or it oozes out. It oozes over that bedrock. And the Play-Doh analogy is good. I realize we talked about that last when it came to the asthenosphere, and that had to do with the nature of that layer of the earth. But a similar sort of texture of property would be imparted to a glacier. Of course, you won't have the heat, but you still have that Play-Doh-y, like that plasticky movement capable in the bottom of a glacier, and that is typified by this displacement of a tube bored in a glacier through time. It shows that it's moving. Of course, we can't see it move. I think I mentioned that if you stand on a glacier and there's not so much wind and there's not so much other noise around, and you listen carefully, you can actually hear it move. You can actually hear sort of this growling, if you will. And that's this base of the glacier moving ever so slowly over the bedrock and grinding on it. And you can really, I'm serious, you can really hear that. Okay, so if this lower portion is plastic and movable, and this upper portion, which we would call the brittle zone, is not behaving plasticky, then it's probably not a stretch to imagine that upper portion would crack in response to the movement of the lower portion and would create something called crevasses. And this picture I took a pilot. We took a float plane trip to a salmon fishing spot in Alaska, and the pilot was a beautifully clear day, and the pilot took us over this glacier, and we were able to fly really low over it. And boy, you can just see the crevasses. Now, I'm not saying it's not a crevice. A crevice is it's a slightly different feature, a crack in a rock. This is a crevasse. I'm not trying to sound snobby or European or anything. This is the term for these cracks on the surface of a glacier. These are crevasses. Looking at another picture of crevasses, here we can see them. These have been weathered a bit. The edges are rounded off by solar heating and wind blasting. It's interesting, though. These are a major problem. When my brothers and I were climbing Mount Rainier in 1981 to look down Mount St. Helens, we were strongly advised by the park officials not to go above 10,000 feet on Mount Rainier. That's a place called Camp Muir, after John Muir. They said up there you should have ropes and ladders. And we said, why? Well, you see, snow can blow over the surface of this glacier and obscure those crevices. It can act like drywall mud on a crack in drywall, and it looks like a nice flat surface. But if you step here, you're fine. But then if you step here, you fall through this thin layer of snow down into a crevasse. And that's exactly what's happened here. Somebody has fallen down. Now, the snow cover's not there. Obviously, you would want to see some snow cover. It may have caved in, because I look over here and I don't see. Here's that skiff of snow. Anyway, somebody has fallen down in, and they're trying to rescue the person. You're encouraged to carry ladders, because oftentimes you'll use ladders to traverse a crevasse. I had a friend an acquaintance, actually. I wouldn't say a friend, I didn't know him well. But his job was actually to drive clear runways in a McMurdo ice station on Antarctica. So he drove a bulldozer, D8 and D9s, I think, at the time, big cat bulldozers, and cleared the runway. He said, well, one instance, he knew of a bulldozer operator that drove that cat, and it fell into a crevasse. Like we see this big four-wheel drive tractor. That's a big tractor. There's a lot of it down too low. It fell into the crevasse, and much like this one, but it fell lower. The guy was able to scramble out, but that crevasse then closed up a day or two later before they could get the cat out and just completely crush the machine. So these crevasses, they're an issue, something you want to pay attention to, and very dramatic things can happen. Okay. That's a nice picture, even if I did take it myself. Usually not very good at it. Usually end up with my thumb in front of the lens. Anyway, so basal slip then, if you got this compression, that's creating a plastic zone here that's causing the glacier to move plastically in that lower region. With that increased pressure then, it's not a surprise that increased melting would occur, because there's increased temperature. And so there can be meltwater right at the base here from that increased pressure, and that can lubricate the base and cause the base of the glacier to slip. Last time I talked about some instances, like Samming's sheep ranch in the Bruggen Glacier in Chile, and then the Hubbard Glacier and the Marjorie Glacier by Yakutat, Alaska, where they suddenly started moving much more rapidly, meters a day, and or meter a day or more, and that's because there's enough meltwater that actually can float that glacier or lubricate its movement, and it will move rapidly for a period of time, and we would call that basal slip. Okay, the next topic we're going to be talking about is glacial anatomy. It's not a complicated one. When we talk about human anatomy, it's a semester-long course. Glacial anatomy, basically we're talking about three items. We're talking about a zone of accumulation, a snow line, and a zone of ablation or wastage. So basically, the snow line here, I'm going to check my notes to make sure, yeah, I got snow line, zone of ablation. I call it Or wastage, yep, that's good. And zone of accumulation. So the zone of accumulation is differentiated from the zone of ablation or wastage by the snow line. Above the snow line is where you have year-round snow covering the glacier and adding to its mass. Below the snow line, you don't have year-round snow, and you have loss of glacial mass. And of course, through time, the snow lines change. Of course, right now the snow lines, well, at least in the recent past, we're moving this way. Now, in some glaciers, it seems that they have stopped, and I'm going to show you kind of an interesting piece here in just a little bit related to that. The crevasses would be evident in the zone of wastage because there's no snow obscuring them. And so if you think about then how glaciers can lose mass, there's basically three ways. They can lose ice by sublimation, in other words, going directly from a solid to a gas to the atmosphere. They can lose mass by meltwater, of course, running into making, in this case, this lake here. And then they can lose mass by something called calving, which is loss of large blocks of ice off the front of a glacial mass. Now, on that issue of calving, I want you to stop the video right now, and I want you to go to the site that's linked in on Moodle, and it's called Chasing Ice. It's about a little more than a 4-minute clip of the largest calving event that has ever occurred. At least that has ever been photographed, I should say, in recorded history. And this is truly an epic event. And if I can get this paused, I'm going to have you look at that. Okay, so let's see if I can get her paused here. Okay, so hopefully you appreciated that video. It's a pretty incredible piece of photography. It's centered around this portion of Greenland right here, and this is the Jacobshaven Glacier. Okay, oops. And so if we zoom in on it, this is what they were talking about, and here you can definitely see how that glacier has receded. Like they were showing you here in the video, how it has receded just since 2010. Okay, you can see it's gone way back to there. And if I go back to Google Earth here, here it is in this imagery date is 2012, so it's receded even more in 2012. But it's kind of interesting, and you know, if you're promoting a narrative that, you know, humanity is destroying the world, this would fit. Could be used to fit that narrative. But it's kind of interesting if you zoom ahead. So let's pull out here a little bit, and we'll go to 2020 imagery date. So this is this year. And if you look at the Jacobshaven Glacier, it's very inconvenient truth here. Well, this is where it was. It was way back here, but now it is advanced to right here. So again, if we look at the clip from Chasing Ice, you can see how it had gone back. The 2010 and the 2012 image on Google Earth, it was back even farther, but now it's back to about 2001. See, look, so if you look at this shaped feature here, about halfway in 2001. So we go back to Google Earth, the 2020 image, about halfway. Right here's the edge of the ice currently. So it seems the Jacobshaven Glacier is advanced back and recovered some of its former mass. Kind of interesting. Anyway, thought I'd just point that out. Nonetheless, that was a huge calving event, and very interesting. Okay, so we're going to take another peek then at some kinds of glaciers. We're going to divide them into glaciers of two sorts. We're going to talk about alpine glaciers, and we're going to talk about continental glaciers. So first we have continental glaciers, the ones we want to talk about first. And this is a valley glacier. And you can see this long glacier existing in a valley. Clever name, huh? And there are these lines on it. I'm going to get to these lines a little later, and but not this time, another day. But I wanted to show you them now. But this is a good example of a valley glacier. Okay. Another type of a alpine glacier would be a Piedmont glacier, and that's this picture that I showed you before. This is a glacier that gets to the base of a mountain. So these would be mountains. This is actually technically a tidewater glacier because it's actually reached the ocean. You could call it either one would be fine. But a glacier at the base of a mountains, we call the Piedmont region, that region, for instance, in the Appalachians, New Jersey would be, part of New Jersey would be on the Piedmont because it's that base of the mountains out to the ocean, that stretch would be called a Piedmont. And you might see that term used elsewhere. So a Piedmont glacier, tidewater glacier. And then the last type of alpine glacier I wanted to mention is a cirque glacier. And you're going to love the definition that I have for this one. A cirque glacier, ladies and gentlemen, is a glacier which occupies a cirque. Don't worry, I'm gonna define a cirque a little later. It's mostly cirque glaciers that you see in Glacier National Park. If we go to let's go outside Yakutat, Alaska again. You'll see valley glaciers. If you fly over this region, you can see some tremendous valley glaciers. They extend great distances in this part of our continent. You can see these long valley glaciers here and here and here. This is the one we talked about, but there are some tremendous ones that extend way back, and these all these valley glaciers here, wonderful examples of them. And maybe a Piedmont glacier there. So, and then a cirque glacier. Okay, let's see, what else did I want to say? We're going to go to continental glaciers. Okay, so I'm going to back out then. And one of the best examples of a continental glacier, okay, the best example, arguably, of a continental glacier would be Antarctica, or the glacier that sits on Antarctica. Would you like to go there? Would you like to visit there? I don't know. My brother has done a marathon in every state. Now he's doing a marathon in on every continent. There is actually a marathon run in Antarctica, but if the weather doesn't allow for it, you basically do a marathon running around a ship's deck, and you'd pay $10,000 to do that. So he hasn't done that one. By the way, he's done 100 of them, and he didn't start doing them until he was 50. So that'll give you some inspiration. He's 68 now and still chugging along. So if you look at Antarctica, let's see, I'd kind of like to go see McMurdo Ice Station. Yeah, let's go there. I think I'm right close. Yeah, there I am. What are you doing? You're not going to the right place. I'm going to get rid of these. And we'll just zoom in on McMurdo Ice Station because it's a research area on Antarctica. So if you want to go to Antarctica, there's actually an airstrip there. You're probably going to end up at McMurdo. Well, maybe I should have stuck with the Shackleton side. I guess maybe I should have stuck with it. Thought I remembered where it was. Oh, it's going to spin us around first. Great. So that's where I want to be. Okay, so we'll zoom in on McMurdo Ice Station here. And believe it or not, there's actually a little bit of a settlement there. There's actually a road there. And look at there, lo and behold, there's even some buildings there. And a fuel depot. This is where a lot of researchers, NSF, National Science Foundation. And so if we look at beautiful downtown McMurdo, we can actually go there. And it's probably what you were thinking it might be. Oh, I guess we're going inside somebody's building there. Didn't really want to do that. It's rather Spartan. Let's see if we can find a street so we can see what an outside look of at McMurdo looks like. Okay, we'll try this street here. I don't know. I'm guessing that, kind of looks maybe like you would have expected it to look. As I say, kind of Spartan, very utilitarian, just what people need to get by. Yeah, kind of a tough place to live unless you're a penguin, right? So it's not very big, a little place clinging to existence on the edge of Antarctica, a research station. And yeah, so that's Antarctica, one of the two main continental ice sheets that we have left in our world. The other one is Greenland, of course. And so if we go to Greenland, I think you're going to be a little bit surprised. This is normally where I would ask you, who governs Greenland? And if you know, you might say Denmark, and you'd be partly right. It's a protectorate, if you will, of Denmark. It used to be Norway and Denmark both claimed it, but now it's Denmark, but they also mostly have self-rule, and it's kind of caught in between. They're working towards self-rule. And but it's a little bit different than South America. Let's go to their capital. It's called Nuuk. I don't know, that's kind of something what I stuck in my kids' mouth when they were crying when they were little. But this is actually the capital of Greenland. And so it's not just an ice sheet anymore. Nuuk is actually a town, I think you'll be surprised by this, of about 20,000. And yeah, if you look at Nuuk, there's a runway there. Pretty impressive town, kind of. In fact, you can go to Nuuk. See, I'm looking for a particular place here. I don't know if I'll find it. Yeah, around in here somewhere. There's restaurants. Let's see if I can find the restaurant. I think this is the one I was thinking of right here. And you can go to, look at the buildings there. This is not at all Spartan. This is Greenland, folks. And you can go in here and then get yourself a pizza and a Coke. I don't know if you thought of Greenland that way, but boy, it's a happening place. There's a lot of new buildings. There's some residential areas in Nuuk, Greenland, and some beautiful architecture going up there, all very new. Yeah, and largely inspired by mineral resources that are being discovered on Greenland. Okay, so that's an ice cap. And if you look at your notes, these ice caps that cover Greenland and Antarctica, they're substantial. We're talking 2.5 miles of ice. And it's the southwestern coast of Greenland that was inhabited by the Vikings. So, yeah, the Vikings, the Inuit. The Inuit came and went. Mostly they came around 1300 AD. There were others before them that came and then left, and the Vikings were here actually probably 1000 AD, a little before that, somewhere in that ballpark. Then after came the Inuit. So it's kind of interesting who's come and gone. Then the Vikings, went away. So yeah, it's been sparsely populated, but now there's a pretty well-established settlement there in the town of Nuuk. But out in Greenland, out in the rest of the continent, if you will, the island, there's a lot of ice, and a substantial amount of ice. 2.5 miles thick in Antarctica, not quite that much in Greenland, but still a lot. Okay, the last thing I wanted to leave you with today is this concept of glacial erosion. So these big hunks of ice, even Greenland and Antarctica, are moving. There's a central zone of accumulation in Greenland and Antarctica, and the ice kind of flows out in all directions from it. Greenland is kind of hemmed in by a coastal mountain range, and so you get these classic looks like this Piedmont Glacier here, or Tidewater Glacier, that's kind of oozing out from between the mountain ranges, and kind of shows you what's going on in these large land masses. So there's always movement of glaciers. On those valley glaciers, boy, it's a little bit easier to conjure up the notion of movement there. It looks like a river of ice flowing downhill. Well, what happens when that ice moves? Well, there's two main things that happen: plucking and abrasion. So as any hunk of ice moves, it's going to pick up any material that it can from its base and carry it with it. And as it's doing that, the base of the glacier here, Oops, I'm going to leave that one up there. The base of the glacier will actually become embedded with those rocks and cobbles, and it will round them, but those rocks and cobbles will act like sandpaper. It will turn the base of this glacier into a piece of sandpaper, and it will abrade the bedrock that it's flowing over. And it will create a very sort of specific kind of sediment, a rock flower we call it, that is unique to glacially impacted areas. If we were in class, I have a jar of rock flour to show you. Some of those piles of rock flour would be blown by winds that would be specific and unique to these large glaciated landscapes. And that rock flour could be blown into piles of fine sand and silt called loess. And I have a jar of that. I'll show you when I can too. If you go to Iowa, and you take, was it Logan? Are you from Iowa? And if you go west towards Council Bluffs from Des Moines, that western edge of Iowa there's a lot of hills. Boy, if you go to Council Bluffs, it's very hilly in that portion of Iowa. And those are called the Loess Hills. Or Loess Hills, it's a German term. You got to really torque your mouth around to say it rightly. Those are huge piles of wind-blown glacially wind-blown sediment. I guess I can say it that way. And it's fairly fertile ground, as you can see when you go through that area, fertile farm ground. Generally speaking, though, glacial sediment is highly unsorted, and that's what we see here. This is a rock and gravel quarry in northern Wisconsin, not too far from here. And so you can see there's boulders and sand and gravel, everything all mixed together. We would call that very unsorted. The rock flour that I was talking about, produced by abrasion, is kind of unique because it tends to be similar in size. But most glacial sediment is unsorted, and we would refer to it as drift. So this would be a big pile of drift. And since it's unsorted, we might also call it till. Glacial till would be another common name for that. Sometimes it can be sorted by meltwater coming off the glacier, and that can create some unique areas. In this part of the country, around Bethel, we'll find pockets of clay. The Anoka Sand Plain, just north and west of here a little bit, is a glacial feature, but that the clay, which will be transported farther than sand because clay is smaller, got deposited in pockets around Bethel, and there are some lenses or pockets of clay interspersed with big areas of sand in this part of Minnesota. So if we look closer at drift, we can see these rounded gravel-sized cobbles of all sizes mixed in with sand and some silt in there. And there again, you can see it. And there's this notion of water maybe moving this through. You can almost see the flow lines in that, maybe melt water coming through it. Yeah, so that's glacial sediment. Okay, I think I'm going to stop there.